This video is about examining and analyzing situations that relate between positive, negative, and no correlation. So before we start with that, we need to talk about what correlation is. So correlation is a fancy way of talking about how things relate to each other. For example, researchers show that there is a relationship between how much fast food people eat and what their weight is. What is the correlation between these two subjects? So think about what you've talked about in health class and seen in commercials and read about, that the more fast food consumed or eaten, the higher a person's weight. So this is going to be called positive correlation because as one variable goes up, so does the other. So the more fast food that you eat, the more the weight is going to go up. So we can represent this correlation on a graph. A graph that shows positive correlation is one that has a positive slope. So if we look at this graph here, what type of slope does it have? We'll see how the dots are mostly rising from left to right. So we're going to say that is a positive slope. And we know that because the data points are rising from left to right. Notice that there is a point that's kind of off from the graph, this point over here, that's going to be called an outlier. So even though it doesn't follow the trend of the rest of the points, there is still a clear positive relationship between the majority of the points. Another type of correlation is called a negative correlation. So an example of negative correlation is the temperature and the amount of layers somebody puts on. So think about how much you wear in the summer compared to what you wear in the winter. So as the temperature increases, the amount of layers decreases. So think about in the winter, you're going to wear sweatshirts and jackets and long pants, versus in the summer, you're just going to wear a t-shirt and shorts to go outside because the temperature is hotter. So the reason that we call this negative correlation is because as one amount increases, the other is decreasing. We can also represent this correlation with a graph. So this type of graph that has a negative correlation is going to have one with a negative slope. So let's look at the graph here. And so we can see that it is going down from left to right. So this is going to be a negative slope. And how do we know? The data points are falling from left to right. So the third type of correlation that we have then is a no correlation. So a no correlation would be like the relationship between how much money someone makes and their favorite sport. There is none in this case. So the reason that it's called no correlation is because there's no discernible relationship between these two topics. We can also represent the correlation with a graph. So in a graph, we see that there's just kind of a big blob of them everywhere, but there's no direction of going up or down. So we notice that the data points are random on the graph. So let's practice looking at some examples of correlation. So determine whether there's a positive, negative, or no correlation between the following: your eye color and your age. Well, remember when you're born, your eyes are pretty much the same color the whole time. So this is no correlation. The amount of hours you work and the money you make. This is going to be a positive correlation because the longer I work, the more money I'm going to be getting. The amount of sleep you get versus the daily temperature. So think about when we sleep, we usually sleep about the same amount of hours. So it doesn't matter if it's winter or summer, we're still sleeping about the same hours, so this is no relationship. The amount of water in a barrel and the time on a hot day summer. So on a hot day. So on a hot day, think about that the sun is evaporating the water. So the longer it's sitting in the hot temperature, the less water in the barrel. So this is going to be a negative correlation. Number 5, the amount of time you spend on school and the grade in school. This is going to be a positive relationship because usually the more time that you're putting in studying, the better that your grades are going to be. Number 6, the number of cars on the road versus the speed of the cars. So think about when it's an empty road, how fast a car is able to go, versus if the road is a lot of cars, like a traffic jam, the cars are moving very slowly. So this is going to be a negative correlation because as more cars are on the road, the slower the cars have to move. Number 7, the time you spend working out and the percent of fat on your body. So the more that you work out, the less body fat you're going to have. So this is also a negative correlation. And number 8, the number of shoes you wear versus where you live. This is a no correlation. Because some people just like to have 1 or 2 shoes. Some people like to have a lot, but where you live doesn't affect how many shoes you may have as a person. Determine the correlation based on the graph. So number 9 is kind of random. I can't really draw a line through the data up or down, so this is going to be a no correlation. Number 10, notice that the data is kind of going down from left to right. So this is going to be a negative correlation. Number 11, see most of the data is kind of going up from left to right. So this is a positive correlation. Choosing the best fit line. So sometimes with the best fit line, when we have a data plot, we can create a line based on the data that's going to best represent it. So what we want to do is we want to draw a line through the points. We want to determine whether the line is going uphill or downhill so we can figure out what type of slope it has, and then cross out options that have the wrong slope. Then we want to look at the y-intercept or starting point on the graph on the y-axis and determine which option is closest to the starting point we can see on the graph. So number 11, we notice that this graph is going down from left to right. So when I draw my line between them, I know it has a negative slope. So right away I can cancel out C and D. Then I notice that my y-intercept is somewhere close to positive 2, which in this case then is B. Number 12, I can see that this data is going up from left to right. So it's going to have a positive slope, so I can cross out A and C. When I look at my y-intercept, it's close to 1, and C has a y-intercept of close to 1 because it's positive 1. Number 13, this data is kind of going horizontal, so I'm going to draw a horizontal line through the middle of the data. So I notice that it's going to be a y equals, because remember, our horizontal lines are always y equals equations. It is above the x-axis, so I know it has to be a positive y-intercept. So I'm between, is it closer to 3.5 or 6? Well, this one's closer to 3.5, so it's A. 14, our data is going down from left to right, which means we're going to have a negative slope, so I can cross out C and D. My y-intercept in this case is closer to negative 2, which is option A. 15, our data is going up from left to right, so it has a positive slope. We can cross out B and D. Our y-intercept here is going to be close to 1, or close to 3, so x plus 3 would be the y-intercept. And our last one, number 16, is going down from left to right, so we're going to have a negative slope. So when I draw my line, it's kind of close to negative 4, which we could see, that's not an option here, but we have negative 5 or positive 5. This could be closer if we move our line over a little bit more, closer to the negative 5, and we see that it is below the x-axis, so it does have to have a negative intercept, so our choice in this case would be negative 5. The last thing we're going to talk about then is interpolation and extrapolation. So when we talk about this, this is when we use to estimate data. So interpolation means the data point is within a given range, and extrapolation means that the data point is outside a given range. So let's look at an example with that. So number 17, we're going to use interpolation and extrapolation when we need to estimate data. The following data represents how much whole milk is consumed since the year 1980. Let T represent the number of years since 1980. So in part A, the equation of the line of best fit for this situation is y equals negative 5x plus 40. This means that the rate is negative 5 and the line is going downward. So if we were to graph the line, we would have our line going down from left to right, and the y-axis is going to be hit at our y-intercept of 0, 140. So notice that in our table, it starts at 1980 and it goes to 1995. So our data range represented by this is 1980 to 1995. So in B, using your equation, estimate the amount of whole milk consumed. So if it started in 1980, 1994 is 14 years. So into the equation, we are going to substitute negative 5 times 14 plus 140. So all I have to do is evaluate that. So negative 5 times negative 14 times 14 plus 140 gets us 70 whole milk. Now, is it interpolation or extrapolation? Well, this case, 1994 is between our range of 1980 and 1995, so this is interpolation. In C, use the equation from part A to estimate the amount of whole milk consumed in 1999. So from 1980 to 1999, that's going to be 19 years. So in our calculator, we're going to do negative 5 times 19 plus 140. And we get 45 whole milk. Now, this is outside the data range because the last year that we have in our table for the data range is 1995, so this is extrapolation. Part D, use the equation from part A to estimate the amount of whole milk consumed in 1983. So 1983 from 1980 is 3 years. So when we do that, we have negative 5 times 3 plus 140. And that gets us 125 whole milk. So this is again in the range that was from 1980 to 1995. So this is going to be interpolation. Number 18, the table shows the data from Jerry's average points per game in basketball in terms of time. Let T represent the number of years in 1990. So the equation of best fit line is y equals 0.20x plus 15, which means the rate is going to be 0.20 and the line is going to be rising or going upward. And this graph is going to hit the y-axis at 0.15. So using the data below, estimate the point averages for the games from 1991 and 2001. And then which is interpolation, which is extrapolation. So looking at our data points, we know that the range is from 1990 to 1999. So the first year that they want us to find is 1991, which is 1 year from when it started. So we have 0.20 times 1 plus 15 gets us 15.2. This is interpolation because it's in the range of the data. And then 2001 is 11 years from when it started. So we have 0.220 times 11 plus 15. So we get 17.2. So we got 17.2 points. Now 2011 is outside of the data range because our data range went up to 1999. So this is extrapolation.